This bare chassis may help you to see the general arrangement of the engine and transmission. The engine is a 6-cylinder side valve job of orthodox design, developing 85 brake horsepower at its maximum governed speed. Most of the electrical equipment is on this side, so let's start by looking at the dynamo. This is driven by the twin fan belts and has a very high output, as it has to take care of the wireless as well as the usual electrical equipment of the car. The 12 volts supplied by the dynamo via the batteries to this coil are here stepped up to a high tension ignition current, which is delivered to each of the 6 sparking plugs at the correct time by this distributor. The whole ignition system is fully screened to prevent interference with the wireless. The starter motor is also on this side. If the pinion should jam, you can put a spanner on the end of the shaft and screw it back. You get at the end of the shaft by removing a cap behind this auxiliary starter button. Let's look at the lubrication system next. On this side of the engine we find the dipstick. This is the dipstick. Below it the oil bypass filter, which is completely self-contained and has to be replaced as a unit when it won't work or after 6,000 miles. And the oil filler. On the other side of the engine we start by looking below the manifolds and find the oil pump, the main oil gallery, the pipe leading to the pressure gauge on the dashboard, and the pressure relief valve which prevents excess pressure in the system. The relief valve for automatically bypassing the oil cooler, the electric oil switch operating the green warning light on the dashboard, the valve that cuts out the oil cooler and its operating lever. This is the pipe through which oil from the sump goes to the cooler. The oil cooler is an oil radiator just inside the water radiator, that thing that looks like an electric heater. The high temperatures caused by running an engine totally encased in armor make an oil radiator absolutely essential. The cooled oil returns to the main oil gallery through this pipe. Just above the oil pump, we find the AC petrol pump, which draws petrol from the tank through this pipe and delivers it to the carburetor. This is a sludge drain plug, and this is the hand priming lever. The petrol is delivered to the carburetor through this pipe. The black object at the top is the oil bath filter through which air for the carburetor is drawn. When the mixture control knob by the steering column is pushed full in, the ordinary working jet is in use and these 2 holes are closed. When the knob is pulled out halfway, a special starting jet is brought partially into operation, and the 2 holes are opened to supply air to this jet. And when the knob is pulled right out, the starting jet is brought fully into operation and the 2 holes are closed again, giving a richer mixture. The warm water in the cylinder block rises into this housing, which contains a thermostat. The thermostat prevents it rising any higher while it is still cool. So it returns by this bypass to the pump here, which pushes it back into the cylinder block. When it gets hot enough for the thermostat to open, it rises to here and goes on into the radiator through this pipe. If the water pressure rises 5 pounds above normal, then a valve to this overflow pipe opens. This pipe equalizes the pressure in the valve housing and the radiator, thus avoiding airlocks. The cool water from the bottom of the radiator is drawn up this pipe and enters the cylinder block through the pump. The high temperatures at which this armor-encased engine may have to run are the reason why that pressure valve was fitted to the system. The boiling point of the cooling water rises with the pressure, and that is why the radiator cap has such a good seal. The system won't work unless it's airtight. When the engine is cold, the water temperature is shown on the dashboard, the level of water in the radiator should be exactly as you see here. No more, no less. When the car is running under normal conditions, it will soon get up to the temperature you see here, between 150 and 180 degrees. The water in the radiator will then have risen by expansion to this level. And if you have filled it right up when cold, you will have lost all the antifreeze mixture contained in that much water. The cooling air for the radiator is sucked in through vents around the engine cover and is expelled through the radiator by a fan. We put smouldering rags into a shovel, and the smoke from these will show you the direction of the draft set up by this fan. Now you'll want to see how the power is transmitted to the four wheels. The transmission is found amidships under the fighting compartment, and this is how it's arranged. The 4-speed gearbox has a dipstick fixed to the filler plug for checking the oil level. A tire pump here delivers air through this pipe to a hose connection on the other side. This lever puts it in gear. This bell housing, of course, covers the clutch and the gearbox is bolted to it. The next stage is the transfer box, which includes the high and low ratio gears. This is the transfer box. This lay-rub coupling transmits the power from the gearbox to the transfer box. There's an oil filler here. The D-clutch unit at the bottom front end of the transfer box enables the front axle to be connected when required. It has a filler plug here. So you see, the power from the engine comes through the clutch, gearbox and lay-rub coupling to the transfer box. This contains a 2-speed high and low ratio gearbox, giving, with the 4-speed main gearbox, 8 forward and 2 reverse speeds. The transfer box transfers the drive to a lower level, from which a permanent drive goes through the rear prop shaft to the rear axle, while the drive to the front axle goes, when required, through the D-clutch unit and front prop shaft to the front axle. This is a 4-wheel drive vehicle, so the front wheels both steer and drive. Here from the front, you can see the steering drop arm, the side steering tube, which has a greaser here, and at the other end here, the steering arm, the attachment for the shock absorber, and the flexible driving coupling, the tractor joint. From the back of this axle, you can see the steering arm, which has a greaser here, and the track rod to the steering arm of the other wheel. Well, that's the Humber armoured car, the vehicle you're going to use. And perhaps before you learn any more about it, you'd like to see something of the factories in which it was made. The size of a country's army today no longer depends on her population. It depends upon the number of men she can equip with modern weapons. The size of our army in the field depends upon how many new weapons that second army, the workers in the factory, can produce. So while you watch the skill with which these cars are being made and assembled, remember that every time your vehicle needs a replacement part, you are diverting some of that skill from its primary job of providing new weapons. And while you watch the vehicle being built, remember that if you give the same care and attention to your driving and maintenance that these men and women are giving to the construction, then when you come to do the toughest job of all, you'll go into action with the confidence that you can depend on the tools you're using for the job.